The Earth may be considered as a uniform scale of radius 6.37 times 10 to 6 meters. Cambridge is a point on Earth's surface that has a latitude of 52.2 north of the equator. As the Earth spins on its axis, Cambridge moves in a circle that is parallel to the equator but with smaller radius. Here is the sun. Okay, so the radius of the circle around which Cambridge moves is 3.9 times 10 to 6. From the geometry, this distance, which is radius of the circular bus of Cambridge, is equal to this distance. Okay, and this distance can be obtained from this triangle if we have the radius of the Earth, which is already given. Okay, so R is the radius of circular bus equal R capital, which is radius of the Earth, cosine 52.2. Because as we know, the cosine is the name divided by the hypotenuse. So the neighbor equals cosine times the hypotenuse. We can get here the answer be 3.9 times 1 plus 3, 4, 5, 6 into 6 meters. It is the speed at which Cambridge moves around the circle. We have a formula for V to be R omega, and omega is 2 pi over the periodic time. As Cambridge is on the Earth, in a fixed position on the Earth, and the whole Earth rotates about its axis in 24 hours, then Cambridge will rotate about its axis, or will make one complete rotation in its circular bus in also 24 hours. So this is the periodic time of Earth and also for Cambridge. The same like another situation when we had a disk and this disk had two clay pieces that are stationary on the disk. We also have their omega to be equal to that of the disk. So always when you have something that rotate with attachment stationary on it, the attachments will have same omega as the object. So here 24 and we will convert it to seconds and the answer will be okay 7.27 times 10 to minus 5. Certainly add second minus 1. After that, we will multiply by the radius, and certainly the radius here would be radius of the plastic membrane, not the radius of the else. Okay? Because we are talking about speed of climate. So this wisdom times we have 283.6, or we can say 284 or 280 meters second minus 1. Student of mass 58.6 kg stands on horizontal ground in Cambridge, determines the magnitude of the resultant force that acts to cause the circular motion of the student. Okay, so we know that FC equals mv squared over r. We have here m, we have v, just going to be with 3, with 4 squared over r radius of Cambridge, which is 3.9 times 10 to 6. So it gives us 1.2 newtons. Okay, 1.2, 1.21. Okay. We want now to show the direction of the resultant force that acts on the students. It will be toward the center of the circle in which Cambridge indicates. When mistake the student makes, the direction towards the center of the earth. It's not correct. On figure, draw labeled arrows from student to show the direction of forces that act on the student to cause the resultant force. How this FC was reduced, it was reduced by the force of weight, which is directed to center of Earth. Okay, this is FG, vertical force between the student and the Earth, or the weight. Okay, and also there is a contact force upward. We need to resolve both of them, and the direction towards the center and direction perpendicular on the direction towards the center. Where is our where is the forces components that coded FC will be if we let this angle to be theta, it will be W cosine theta. Okay, here is W, here is theta, here is W cosine theta. If we note the geometry here, we'll find that this angle also is theta, so this R cosine theta. So only W cosine theta to left and R cosine theta to right are contributing to the FC. Both the vertical component of R or of the weight has no contribution for FC.